Okay. Yeah, thank you for having us here. So as said before, we will have the session in English, but you can also ask any questions in Japanese. We will try to do our best to answer. So we are two people today. So I will do some introduction and then we'll hand over to my co-speaker. So the session is about scaling to large clusters in EKS. We want to share some of our operational experience we have gathered over the couple of years we have been using EKS, and also talk about some challenges that we had. So we don't have much time, so let me just briefly show you the agenda. So first of all, I will make an introduction, and then we will go over some of our scaling challenges. Here we have 5 listed up. So we try to go as deep as we can in each of them and try to explain what challenges we had here and how we solved them. Lastly, we also want to talk a bit about our vision for the next year or two. And finally, end up with a conclusion about some recommendation, what you can do for your services. So to start with the introduction, first of all, about me, I'm Marc. I'm the group head of the platform backend team. I've been at SmartNews for about 3 years. So I've been with the company since the beginning of our EKS usage. So I started from very small clusters to a very big cluster now. And then we have Luke with us, who is today kind of the main operator and main maintainer of the Kubernetes clusters in SmartNews. So he has a lot of good ideas about improving our scale. Okay. So next about SmartNews itself. So you might have heard about us. So we are maybe news or information aggregation application. Our mission statement is to deliver the world's quality information to the people who need it. So we have so far somewhat global user base with a focus on Japan and the United States also since a couple of years. So you can see one screenshot here on the right-hand side. So you might have seen it before. So then about our EKS usage. So as I mentioned earlier, we started using EKS for some smaller services in the beginning of July 2019. So mostly it was some Java applications that we were running on the backend, some not that important services. But around the mid of 2020, all of our new services were kind of scheduled on EKS. So we have been fully embracing EKS, and it has helped us a lot since 2020. So then from the next year, 2021, we started also to deploy some stateful services on the clusters, stuff like Kafka or ScalarDB, so that that posed another big challenge for us. But I think right now it's a fairly positive experience. Lastly, by the end of 2021 and also a big part of this year, we've been migrating some backend analytics workload onto EKS, so that has caused our scale to increase significantly. And maybe to give you some overview of how we manage EKS, I want to talk a bit about our cluster topology. So we separate our clusters into 3 dimensions. The first dimension is environment. So we have different clusters for development, staging, and production, so that we can upgrade or do some testing and development clusters and not impact any production clusters. The second dimension would be the region. So as I mentioned earlier, we have a large user base in the United States as well. So for that purpose, we are running clusters in the Virginia and Oregon regions of AWS, aside from the Tokyo region. And I think that also has been very successful so far. And then lastly, inside the environment and region, we also separate between different business processes. So we have different clusters for different processes. One is the biggest cluster is the news-related cluster, and then we have a somewhat smaller cluster for our ads-based processes, and then some other smaller clusters even. So this is the three dimensions which we use so far. Then lastly, a bit about the scale. As you can see, it has been picking up quite a lot since the last year. So right now, this is only for the biggest cluster that we have. We have about doubled the node count over the last year to about over 1,000, maybe at peak we are 1,500-ish right now. Yeah, coming with this big scale out, we had some challenges. So without further ado, I want to actually give over to Luke to talk about the scaling challenges that we have faced.
Hello, everyone. I'm Luke from SmartNews platform team. Yeah, let me share about the challenges we have faced in SmartNews. So first, let's start with the autoscaling. So about autoscaling, we have mainly two challenges here. As Marc mentioned, our workloads have increased a lot recently, almost doubled compared to last year. Another thing is some features, the load of some features change a lot during the day, like some push of a notification feature. So as for the solutions, first, there are actually two types of autoscaling. The first one is the port autoscaling. Here we are using open source, which is called the CatEye. It supports many scalers here, but mainly we are using the Chrome one and the CloudWatch one. Another scaling is about the node autoscaling. We are using the class autoscaler, which is I think is a well-known software. So I want to talk a little bit more about the node autoscaling. Here is our node group design. You can see we have a logic node group here, but in the AWS side, we created the ASG by each zone. So it's like a one node group maps to several ASG. The design, there are kind of two reasons here. The first one is like we want to do some balancing and HA across the zone. Another thing is it would be easier to change the priority of the cluster scaler for each group, which I will talk about next. So about the cluster scaler itself, we are doing something I call the dynamic priority. So first, cluster scaler, it supports different expanders. So here we are using the priority one. Simply speaking, it's like you can see the numbers here. So the bigger number, the higher priority, which means the cluster scaler will use this node groups first if both of the groups match the requirements. So by doing this, we can change the priority based on several factors. For example, you know there are many different EC2 instance types, the general one, the memory one, and the CPU one, which the CPU and the memory ratio is different. So you want to make sure most of the resources are used. You don't want to waste any of that. So based on the actual workload, we want to make sure the entire utilization better by like, for example, like if some workload requires more CPU, we will push the CPU node group at the top. So say we are using it first. Another factor is like recently we are using a lot of support instances. So because of the group design here, we create the group in each zone. So we collect the price metrics based on each zone. So we will make the cheapest one be the highest group. And also another thing, like if there are many interruptions happening in a zone, which means that there would be a high chance it will happen again. In that case, we will decrease the priority of that node groups. So that kind of reasons we are doing this dynamic priority thing. Okay, the next one is about the container network. So I guess most EKS users are using the AWS app, which is very convenient compared to Flannel or Calico. It takes care of the routing thing. But with more and more nodes, we actually face some like serious issues here. It's like it's the pod failed to start because there's no IP. So from the logs, we found that actually two main issues here. The first one is called the efficient address. It just says there's no enough address to use. Another one is simple. Is that reach the EKS API limit. So before we started to do any change, first thing we did is we actually read analyze its source code. The reason we do this is because the AWS is very important, a very crucial component to us. I mean, to EKS. If it's down, it's like it will affect your service. So that's we decided to understand deeply, so we can kind of handle all the kind of issues, no matter what it is. So after that, we made two changes here. The first one is we use the custom network instead of the default one. Another is we enable the prefix delegation. So first, let me explain why there's a efficient IP issue. So by default, the AWS app will get the pod IP from the same subnet of the node. For example, this one. Let's say this is the subnet for a node group. So the node will use this subnet, and the pod also will use this subnet. But the problem is the cluster scaler is not aware that there's something else using the same IP. So when it needed to scale up the node group, it will check, okay, there's still IP out there, then it will do the job. But that means the total IP, the available IP will decrease, which is not enough for the pod to use. So that kind of a competition here. So using customer network means we use totally two different subnets for nodes and for pods, which like there would be no complete anymore. The next is about why we got the EKS API limit issue is because of the kind of the behavior of the AWS app. So if you this part actually from the part of the source code, the AWS actually keeps a cache of the available IPs, which is based on the warm target you set. So it will try to get or release based on the actual in-use IP count. So let's say if you have a node, and in that node, the many pods are created and deleted frequently, then the AWS will try to request the IP and release them, which will make the EKS AWS API call. So yeah, it will read, probably it will exceed the API limit. So with the prefix, instead of apply IP one by one, it will actually get the one whole subnet. It's the 28-sider. By the way, it's hard coded, so you can change it. But most time, that's enough. That should help you to avoid the API limit issue. Okay, the next one is about the DNS. So about DNS, we had two challenges. The first one is sometimes there's a very high latency. I guess I remember about 200 or 300 milliseconds. Another one is also the AWS API limit, which is the AWS DNS API limit. So we took two solutions here. The first is we enable the non-local DNS cache, and then we also increased the default TTL for the external domains. So the local DNS cache, I guess this is probably well known, already supported by the Kubernetes. So simply speaking, it's like we have the core DNS running on auto node at the daemon side, and the requests from the pods in that node will go to this pod instead of the upstream one. So it did a little trick by using the IP table rules. So you can see here the configuration is just the simple core DNS configuration. For the internal request, it's just forwarded to the in-cluster core DNS upstream pods. For the external one, it will go to the AWS DNS server. So by doing this, we had a kind of big improvement here. So for the latency, you can see the 99% request, the latency is probably under 15 milliseconds. And in each node, the request count external is about 15, which is quite small. Okay, that's all about the DNS. Next one is the API server, the EKS API server. So as you know, the EKS is a managed service by AWS. For the CPLAN, or the API server or etcd, you actually can't see them, you can't log in. So and the problem is we had some outages, like a very serious one. When that happened, like we couldn't access the EKS API. It's not one. I'm not just talking about the operator, also like the Kubernetes and the other operators. They couldn't access the EKS API, and even sometimes it could. Like the latency is very high. It took us like a minute, several minutes to get a response, which caused many our pods kind of unable to handle the requests. So the problem here is we never paid attention to the EKS API server before, because we thought like it's managed, so we don't need to worry about them, which yeah, it's a big mistake. But since like we don't have the permission to change some configuration or do further tuning, so what we can do here is the first thing is we set up a monitoring, we collect the metrics, we set alerts, create dashboards. Another one is what we are trying to do is we want to put up a proxy server in front of the EKS API server, because we want to do some like the reach limit check and some filtering, but this is still in process. So as for the monitoring, we actually are monitoring many metrics here, but here let me share the most important three metrics, I think. So the first one is the QPS. The interesting here is you can see there 4 nodes here, right? You actually can see the API server IP changed at this moment. So this is actually because the EKS has the scale-up mechanism. It will detect the kind of CPU memory load and also the request number. It will do the scale-up first. That's why you can see the IP change here. There are 2 new servers after this moment. And if the request or the load keep increasing, I suppose there would be more nodes later. So the monitoring here is like you want to know how many requests you have, and you want to get alert when there's a kind of a sudden big increase, like to 1K, and you want to know if the EKS scaled or not. So that kind of alerts and metrics you want to see here. Yeah, the next one is for the 500 response, like what which API not working, or is or the API if not working or not. And latency. So based on the cluster scale, the least API would take longer. In our case, it's almost 10 seconds, 6 seconds. And yeah, and the next one is about the cost. So yeah, as you can see, with such increase, the cost also increased significantly in last 6 months. So for the cost optimization, we did kind of 3 things here. The first is the resource quarter. This is the Kubernetes concept. You can set the resource quarter for each namespace, which will limit the user. They can't use more than that. And also, we are trying to use more and more spot instance instead of the on-demand one, because it's cheaper, much cheaper. And also, we want to know, like, if is there any waste of the resource. User request more, but they don't use them. So for the first two, it's I guess not much to talk. It's already, you can check the Kubernetes documentation and also the AWS official guide. So for the last one, the resource utilization. So here is like this node. Is the example of a node. Let's say here is the request, and here's the actual usage. So you can see there are like almost half of the memory are not used, even they request so many. As for CPU, the same thing. So to get this information, we are using the software which is called Kubernetes to get such metrics to find out which workloads have such issue. And I also mentioned the dynamic priority of the cluster scheduler, which will help to do that. So there are two issues here. The first issue is the request, between the request and the actual usage. Another one is the CPU and memory ratio. So in this case, you can see the CPU efficiency is not that bad. It's 15%, but because of the memory problem, even there like sufficient CPU out there, no workload can use that, because they also request some memory. That's why we want to change the instance type based on the actual requests. Okay, that's all the challenges that we have. Last, I want to talk about what we want to do in the future, the vision. So first, actually, we didn't mention any DevOps thing here, but we currently are using Terraform to manage everything, and also we set up a lot of CI jobs to apply the changes. It works good. It worked well like before, but now we have more and more resources, and the scale is still keeping increasing. Actually, only 1/3 of the whole Smart News workload running on EKS. So in the future, we definitely will have more. So that's why we want to use the operator instead of the manual operation here to manage the whole EKS and also the other AWS resources here. I guess you probably know there are many open sources out there, like who can manage a Kubernetes cluster. But here we decided to do by our own. I can't like talk about more details here, but we still decide to keep using Terraform as the actual manager. Like I think the Terraform concept is pretty good, everything as code, but we are using the operator to do the watching, to do the reconciling here. Yeah, that's the operator thing. And another one is like we are not just have a larger cluster, we also have many clusters, and in the future we expect that would be more. So with the more and more cluster, is not just difficult for us to manage, also for users. They need to have like use different templating, manage different configurations for each cluster, for each region. So we are thinking like maybe create some virtual layer on the top of all the clusters, so user don't need to worry about the details behind that. But this is just the kind of the idea. We don't have any plan yet. So okay, at last, let me talk about the lessons we have learned. So first is like as I mentioned, we started to do many things when the scale start to increase, but actually it's better to be aware of that in the first place. When you design something, when you like introduce some workflow, always keep it in mind what you should do when the scale doubled or tripled. The next one is like for the core components, like the CI, like the cluster scaler or others. Be sure like you have a deep understanding of that component. It's not like you read the user guide or you can Google. It's more like you know how it works, exactly how it works. It's source code level, so then you have the confidence to handle any kind of issues when that happens. The last one is like be the cost sensitive actually since the beginning. So I said that we introduced the resource quarter, but we didn't do that in the first place. If we did that, that would save us a lot of trouble. So yeah, but I guess the developers want to be happy about that, but as like kind of the platform or the SRE, you should be aware of that all the time. And yeah, okay, I think that's all from me. Thank you for listening.